There's a huge chain of events that has to happen for a forecast to get delivered. There's a lot of people with a lot of different expertise working together as a team to create this huge chain of events to make sure that when a forecaster in my position is sitting there making a decision, that warning is turned around to you in a matter of minutes.
Spectrum is the fabric of really our operations. It really is the full circle. You start with the sensing, you download that data, and then you distribute that data through Spectrum, either through satellite or even through your cell phone, right? That's how you get your weather app.
NOAA is an environmental agency, and as such, so is the National Weather Service. So NOAA, the National Oceanic and Atmospheric Administration, has a mission where we're looking at everything essentially from the ocean floor to the surface of the ocean to the atmosphere, and as well as monitoring activity from the sun.
NOAA provides everything we see daily in terms of daily weather forecasting, climate monitoring, space weather alerts like solar flares. We also have our fisheries that do coastal management, fish management, as well as our hurricane hunters.
Spectrum is everywhere. You don't see it, but it's everywhere, right? You have a cell phone, you get your weather data daily, by hour, all that is done with our satellites and our radars. Our systems, they cover a whole wide range of bands. We go from VHF, L, S, X, and so it's a lot.
We have what we call the NEXRAD dual pole Doppler radar. Doppler, of course, is something that goes out and hits something. When it comes back, it's either going to come back faster, slower, or the same, and based on that we can determine how fast something is moving and which direction something is moving.
So the Radar Operations Center is a tri-agency organization. We are comprised of the National Weather Service, the FAA, and the Air Force. And our responsibility is the life cycle sustainment of the NEXRAD weather radars. The radar is essential into keeping people safe from severe weather and hurricanes and flash floods and winter storms.
We are inside of our test next generation weather radar, NEXRAD, otherwise known as WSR-88D. It is a S-band weather radar, generally from 2.7 to 2.9 gigahertz. So the radome it's a geodesic dome, and it's made out of fiberglass. Fiberglass at a low density is RF transparent, so we can actually radiate right through it. And that basically protects all this from the elements. Because the one thing you don't want is a weather radar that gets taken down by weather.
Our job is to make sure those weather radars, there are 159 of them across the world, and our job is to make sure that they are running when forecasters need them most. And our job is to make sure that those radars will be sustained and operational well into the future.
We have our geostationary satellites. We have our JPSS. We have our low Earth orbit satellites, and we also have satellites that are at the midpoint between the Earth and the Sun, where we do a lot of measurements and observations for sun space weather.
For wildfire support, these satellites can actually detect hotspots. So when a fire develops, you'll see it on the satellite imagery. Some of our forecast offices have developed a way where they see a hotspot, they can drop a point on there and quickly send an alert to local officials and emergency responders. And they've said that some cases they actually get the notification from the Weather Service before they get a 911 call from somebody on the ground.
The importance of clean data ensures that forecasters have accurate information to issue timely forecasts and warnings. So with spectrum interference or other types of contamination to the radar data, that can impact forecasters' ability to see fast evolving signatures, such as a tornado signature or a downburst signature, or even obtain information on flash flooding and precipitation estimates.
There's a larger and larger appetite for wireless communications and which use spectrum. I would say the biggest challenge is that it is a finite resource. We have IoT devices, Internet of Things. We have military operations that use radar. Spectrum is also used by your cell phones, your Wi-Fi.
I think everything related to spectrum is really important to have different backgrounds. And here at the Radar Operations Center, we see that every day because weather radars have to do this blend of things such as the hardware engineering, the technical aspects of how do you spin a giant antenna around, the computer technicians and software that have to go to get that data to a reader, and how you actually do stuff like graphics design so people can look at your data and understand it.
When we go home each day, we have a sense that we have contributed something not only to our own local community and our neighbors, but also to the nation. We take a lot of pride in the fact that Americans across the country and our service members abroad can receive accurate weather information from our radars.